acid will exhibit different properties when it is dilute and when it is concentrated. So these chemical properties, when it is in the dilute form, we can have the first set, that is acidic properties. So dilute hydrochloric acid exhibits acidic properties, which we can see one by one. Okay. Now the first one, it can react with active metals. To undergo displacement reaction, hydrochloric acid to give zinc chloride plus hydrogen. So it liberates hydrogen. Same thing happens with magnesium with dilute hydrochloric acid to give magnesium chloride plus hydrogen. Iron reacts with dilute hydrochloric acid to give you iron 2 chloride plus hydrogen. So in all these cases, hydrogen is evolved. This is displacement reaction with active metals. The next set of reaction is neutralization. What is neutralization? When it reacts with a base. Neutralization with bases. Bases can be of two types. Hydroxides as well as oxides are called bases. So if you take copper oxide, this would react with dilute hydrochloric acid to give copper chloride plus water. See, base plus acid to give salt plus water. Similarly, ammonium hydroxide, which is a weak base, also reacts with dilute hydrochloric acid to give you what salt could be formed. Just split it up this way. Then you get ammonium chloride plus water. So these are neutralization reactions with bases. The next one is with carbonates and bicarbonates. With carbonates, metallic carbonates and bicarbonates, you would get salt, water and carbon dioxide. Let us take sodium carbonate, reacts with dilute hydrochloric acid to give what salt could be formed would be sodium and fluorine combines to give you sodium chloride, plus we would think of carbonic acid, which is H2CO3, but it is unstable, which breaks down to give you water and carbon dioxide. Similarly, copper carbonate can react with dilute hydrochloric acid to give copper chloride plus water plus carbon dioxide. Okay. Supposing we take a bicarbonate like sodium bicarbonate. This also reacts with dilute hydrochloric acid to give you sodium chloride plus water plus carbon dioxide. So these are the reactions with carbonates and bicarbonates. Okay. The next reaction is with sulphides and bisulphites. With sulphides and bisulphites. Here we would get, say supposing we take sodium sulphite. Okay, this combines with dilute hydrochloric acid to give you, again there is a salt, that would be sodium chloride, plus water plus sulfur dioxide. Okay, in the place of carbon dioxide here, because it's a carbonate, CO3 is there, here SO3 is there, so sulfur dioxide is formed. Even if you take sodium bisulphite, again reacts with dilute hydrochloric acid to give sodium chloride plus water plus sulfur dioxide. Okay, so the difference between these two, if you see, when carbonates react with dilute acid, you get carbon dioxide. Sulphides give sulfur dioxide. How to differentiate? Both these gases will turn lime water milky. Okay, both, say, carbon dioxide and sulfur dioxide turns lime water milky. Then what's the difference between these two? Carbon dioxide will have no effect with potassium permanganate and potassium dichromate, no effect. But when sulfur dioxide is, when we pass it through potassium permanganate, which is pink in color, it becomes colorless. And potassium dichromate, which is orange in color, turns green. So these are the differences between carbonates and sulphides. This gives you a rotten egg smelling gas. So we have three compounds: sodium sulphide that reacts with HCl, dilute. What could be the salt that is formed? It would be again sodium chloride, and the rotten egg smelling gas is hydrogen sulfide. Okay. Similarly, it can also react with copper sulfide with dilute HCl, giving copper chloride plus hydrogen sulfide. Now, this reaction is important because there is a color change. Here, this copper sulfide is black, whereas copper chloride becomes blue. The next one is iron sulfide. This reacts with dilute hydrochloric acid to give iron 2 chloride and hydrogen sulfide gas again. So these are the reactions with sulphides. So with active metals, hydrogen is liberated. With bases, salt and water, neutralization happens. With carbonates and bicarbonates, you get salt, water and carbon dioxide. With sulphides and bisulphides, you get salt, water and sulfur dioxide. With sulphides, you get salt and a rotten egg smelling gas, that is hydrogen sulfide. Second set of reactions are called precipitation reactions. This also involves dilute hydrochloric acid, and there are two reactions with two nitrates. One is silver nitrate and the other one is lead nitrate. Both these things undergo something called double decomposition reaction. What's happening here? See, this breaks down into silver and nitrate. This also breaks down into lead and nitrate. This breaks down this way. So, what do we get here? We would get silver chloride and nitric acid. Here we get lead chloride and again it is nitric acid. Okay. Now lead chloride is PbCl2. Both these silver chloride and lead chloride are precipitates. Precipitates we denote with an arrow mark that directs downward, and this forms a white precipitate. In short, we call it as PPT. This again is a white precipitate. Now, this lead chloride has a difference. It does form a white precipitate in normal temperature, but when it is heated in hot water, it dissolves, so it does not form a precipitate. In cold water, there is a precipitate. So, these are the two precipitation reactions of dilute hydrochloric acid. The third reaction that we have is with ammonia. Reaction with ammonia. So when hydrochloric acid, this we can take concentrated HCl in a test tube. So you take concentrated HCl and you just bring a glass rod that is dipped in ammonia near the test tube, and you can see dense white fumes. This dense white fumes is basically these two reactions, HCl plus ammonia, to give ammonium chloride. This forms the dense white fumes. Now, there are three things that we are looking in with observations. With silver nitrate, it gives you a white precipitate. With lead nitrate, again a white precipitate. With ammonia, you get dense white fumes. All these three tests, these are tests of identification of hydrochloric acid. So you can say them as tests for identification of hydrochloric acid. So with that, we finish our chapter on hydrogen chloride gas and hydrochloric acid.